Welcome, we're going to do our conditional probability video, so let's get to it. First of all, conditional probability. Conditional probabilities is probability with some conditions. So, given event A and B, conditional probability is the probability of event B occurring, knowing that event A has already occurred. Okay, so we're talking about saying what is probably this thing happens given something already happened. The way that we write that is the probability of B given A. So that line right there, we use the word given. So we would read that as the probability of B given A. And our formula to do that is basically the probability of both things occurring, so the probability of A and B over the probability of A. Okay, so let's take a look at our first one. Mitchell drew a card from a standard deck of playing cards. What is the probability that he drew a queen given that the card was red? Okay, so he drew a queen given that the card was red. Well, my first question is, here's our given. So how many cards were red in the deck? Okay. Well, if you think about it, there's 26 red cards. So that's our given. We usually like to put our given on the bottom. And out of those 26, how many could be queens? Because we have basically hearts and diamonds are our red cards, and we have 2 of each, so that would be 2 out of 26, or 1/13. Okay? So given that he picked a red card, well, how many red cards? 26. How many of those 26 cards could be queens? Well, we could have a queen of hearts and a queen of diamonds. So 2 out of 26. A number from 1 to 100 is randomly selected. What is the probability that it's a perfect square given that it is an odd number? Well, how many odd numbers are from 1 to 100? Well, there's 50 odd numbers, right? So odd numbers. And how many of those odd numbers are perfect squares? Well, we could try and figure that out by going through it and listing out all of our perfect squares. So we could do that. So perfect squares would be 4 is a perfect square. That's 2 squared. 3 squared is 9. And then we have 4 squared is 16, 5 squared is 25. What you're going to notice is every other one is odd, so we have even, odd, and so on, all the way up. So let's just keep on going. 25. So 6 squared is 36. Then we have 7 squared is 49. 8 squared is 64, 9 squared is 81, and 10 squared is 100. So even, odd, even, odd, even. So how many are even? 5. So 5 out of 50. So given I'm only looking at odd numbers, I'm sorry, I did that wrong. We also have to include 1, 2. We're looking at odds, I apologize. So 1, 2, 3, 4, 5. So we still have 5 for either one, so it doesn't matter. But so we have 5 that are perfect squares given that I'm only looking at the odd problems, and we can reduce that to 1/10. All right, number 3, it says there are 62 people that take yoga and 48 people that take spin. 15 people take yoga, also take spin. If a person from this group is selected at random, find the probability that he or she takes yoga if you know they take spinning class. Okay, first statement. If you know they take what? Spinning class. So I'm only looking at the spinning class people, so that's 48. So 48 goes on the bottom because that's my given. I can only look at the people that is given. So I'm looking at the spinning class first. Okay. What's the probability that I grab someone from there that also takes yoga? So what is a good idea is just drawing a quick little Venn diagram. Okay, so here's spin, here's yoga. Okay, it says that we have 15 people do both. Okay, so 15 people do both. That means 33 people plus 15, that makes 48. So 33 just do spin. Of those 48, 15 also do yoga. And then over here, we can also say 47 do yoga, plus that 15, that would give me 62 people do yoga. So if you know they take spin, that would be 48 people. What's the probability they do yoga? Well, how many people that do spin do yoga? And that would be 15. Okay? Of the 30 students in Mrs. Smith's math class, that's not mine, 13 are athlete and 9 are in the band. 3 of the athletes are also in the band. If one is chosen at random, find the probability that the student is in the band if you're known that they are not an athlete. Okay, well, I have 30 students, 13 are athletes. So how many are not athletes? Okay, so not athlete. Well, 13 minus 30, we get 17 are not athletes. So out of the non-athletes, how many are going to be in the band? Well, let's take a look. We got another Venn diagram we can draw. Okay. And this could be athlete. And this could be band. So 13 are athletes, 9 are in the band, 3 are in both. So we got the 3 in the middle. So 3 to get 9 total, you're going to do 3 plus blank equals 9, so that's going to be 6. And then 13, this has to be 10. So 10 are just straight up athletes, 6 are straight up band members, and 3 do both. So the probability that you have not an athlete, okay, so in the whole class, so again, we don't have this, these numbers don't necessarily add up to 30. We're just looking at athlete and band members. So there's 17 people that are not athletes. So what's the probability that they're in the band? Well, these 3 won't be able to add it because they're athletes, but these 6 are definitely not athletes, and they're in the band. So we're going to get 6 out of 17. Okay. Now we're looking at what's called two-way tables. Two-way tables give us a table that records data on 2 different categories. Example, the table shows the results of a poll of 50 randomly selected students who asked whether they prefer to watch hockey or football for each probability, or find each probability. Okay. So prefer football given they're a girl. So given they're a girl, so we got to only look at the girls. So if we total up the girls, that's 22 girls total. So given that they're a girl, 22, they prefer football. So of the girls, we're not even looking at the boys. We don't care about the boys. Which prefer football? 6 of them. We can reduce that to 3 over 11. Okay. Now, what's the probability of a boy given they like hockey? So we have to only look at the hockey. So there's 26 people that like hockey. And if they're a boy, so we're only looking at hockey. Now we're not looking at the football. 10 of them are boys. And we could reduce that to 5 over 13. So two-way tables are a little easier because we have a lot more information in front of us. We don't have to try and pull that information out. Let's flip it over. Get some more work with this. Okay, so we have a new table here. The table shows the results of the poll of 150 students, and they're asked if they take French or Spanish. Okay, so what's the probability of a 7th grader who takes French? Okay, so what's the probability we grab a 7th grader who takes French? Well, this is pretty easy. There's no given here. I'm just asking 2 different things. So where's my 7th graders that take French? Well, there's 25 7th graders who also take French out of the total 150 students. So that's 1/6. So the probability I hit a 7th grader that takes French is 1/6 of this poll. All right, next. An 8th grader that takes Spanish. Okay, given that they take Spanish, I can only look at the Spanish column. So if I add all this up, I'm going to get 868. So out of the people that take Spanish, so I'm only looking at Spanish classes, which is 68. What's probably their 8th grader? 33 over 68. Okay. What's probably the French given they're a 6th grader? So we have to add up all the 6th graders. So that's going to add up 23 and 19, which is 42. So there's 42 6th graders. And how many of them take French? 19. probability of 7th grader, given that they take French, well, I add up all the French students, there's 82. And what's the probability that they're a 7th grader? That's going to be 25. So these two-way tables are a lot nicer. You just got a lot of times the given is what we put on the bottom, and the top is what we want to find the probability of. A little faster way. All right, table shows the result of randomly selected juniors and seniors who were asked to attend prom. A junior that did not attend prom. Okay, so again, we're looking at the whole data set here, so we have to add up the whole data set. If we add all of this up, all the seniors and the juniors, we're going to come up with actually 200 total students. Okay, so 200 would be our total for everything. And we want to say that they did not attend prom. So I'm looking at the juniors. 56 did not attend prom. And we can reduce that to 7 over 25. Okay, they did not go to prom given that they're a senior. Well, only looking at the seniors, so 116 are seniors, which did not attend the prom, 19 of them. Okay. Juniors, given that they attended prom, well, how many attended prom? That would be 125. So given, out of that 125 that were prom, which ones were juniors? 28. All right. Our last topic here is frequencies. So we have a joint frequency, joint relative frequency, the values in each category divided by the total number of values, and then the marginal relative frequencies found by totaling each row and column. Okay. So the table below shows the number of first class, coach class passengers on a plane to check one bag, two bag, or no bag. Find the joint relative and marginal frequencies, then find each probability. Okay. So basically this is asking us, first of all, what's the total that we have for all people in our sample? Okay. So we could do that a couple different ways. We could add these rows up. So let's go ahead and do that real quick. I didn't pre-add these already, so let me just take a second and add these up. So we got 30 people in first class. We have 130 in coach, so we have 160 total people. Okay, so 160 total people. If I add it this way and add them up, we get 160 as well. So our relative frequency is the value in each category divided by the total number of values. Okay, so this is going to be 160. All of these are going to be 160 divided by 160. So first class with two bags is 16 out of 160. Okay, I'm going to turn these into percentages or decimals. So that's going to be 0.1. If you put that in your calculator. Okay, so one bag is going to be 12 divided by 160. And if we do that, we should get 0.075. Okay, I'm going to zoom in to our table here. Okay. Their first class with two bags only, or zero bags, sorry, is 2 out of 160, which would be 0.0125. And if you add all that up, we get 0.1875. This would be our marginal relative frequency. Okay, so here's the marginal relative frequency. So we're going to fill this in. I'm going to kind of go a little bit faster because I showed you how to do it once, but here we go. The marginal relative frequencies are going to be all of the totals, okay, versus the joint relative frequencies are going to be all the ones on the interior. Okay, so our joint relative frequencies are going to be all of these guys on the interior, and the totals are on the outside. So I'm going to fill these in. I pre-did them. Again, to get this number, we add those three. And if you add these two together, we should get 1, because the probability, we always have a probability of 1. So we're including the whole data set, because we're dividing by 160, and the total is 160. So this always has to equal 1. If you don't get that equal to 1, And we know that there was a mistake made somewhere. But there we go. So marginal frequencies on the outside, joint relative frequencies on the inside. Okay, it looks like I got a Facebook notification. Cool. All right, let's move on. Probability a coach class passenger that did not check any bags. Okay, well we can actually just look at this. Coach, 0 bags, 0.1125. Now we want a percentage, so we're going to move the decimal over twice. So that's going to become 11.25%. Okay. A first class passenger that checked at least 1 bag. Okay. First class checked at least 1 bag. So we have to combine both of these, right? So we're going to do 0.075 plus 0.1, and that's going to equal 0.175, which is 17.5%. Coach class, given they checked 1 bag. So how many people checked 1 bag? We got 0.45 checked a bag. And given that they were in coach, so out of this, the coach was 0.375. And if you divide that in your calculator and turn it into a decimal, 83.3%. So it's very likely that if you checked 1 bag, you're probably in coach. Okay. Check 2 bags given you're in first class. Okay. Well, how many people are in first class? A total of about 1.875. And how many of them checked 2 bags? 0.1. So if we were to calculate that out, we get about 53.3 repeating percent. All right. So there you have it, guys. We'll talk more about this later.